So where we left off yesterday with the permutations and fundamental counting principle with distinguishable permutations, basically where you have repetition. So like in this case where it says how many distinguishable permutations of the letters in basketball are there? So it's like if you would create new words, okay, that obviously don't exist, but rearrange things. Are you going to know the difference if I would basically take the word basketball and if I would flip those two letters and I rewrote it? Does it look any different? I switched the B's. I switched the place of the B's. I even switched the place of the L's too, and you didn't know it. It's like magic. Does it look any different? No, so you can't tell. Okay? It has to be distinguishable, okay, or you have to be able to see the change. So whenever I do it, like if I switch the B's around, or I switch the A's around, or the L's in this case, because those are the ones that you're not going to notice if there's any change. But if I would rewrite it as this here, basketball, you notice the difference, right? Okay? Because I'm not moving things that are the same, I'm moving distinguishable letters in this case, okay, or parts. So whenever I do this, I set everything up the same way. I still need to figure out how many different values I have. Okay, so how many different spaces? Okay, I have 10 spaces. So whenever I set this up, the top number is going to be the amount of spaces, okay, to the factorial. Then I need to go and look and see how many different ones repeat themselves, or which letters in this case are repeated. And how many times do they repeat? How many letters that are the same? Like I have B, I have A, and I have L that repeats, right? How many times does the B repeat itself? 2. Okay. How many times does the A repeat itself? 2. And what about the L? 2 again, right? So out of all of those values, any time that something repeats, and however many times it does repeat, all I'm going to do is I'm going to divide it, and I'm going to go 2 factorial, 2 factorial, and 2 factorial. So each time I have something repeat itself, and however many times it repeats itself, that's going to go on the bottom side of my fraction, my division, whatever you want to call it. So then whenever if I would actually have to, like if I would write this out, again, you're probably just going to type everything straight out, which is completely fine. If I go 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now, you don't have to do it this way. The one thing I would tell you, if you type it into your calculator, I would put the 10 factorial in a parenthesis, and then divide, and then put the 2 factorial, 2 factorial, and 2 factorial all in a parenthesis as well. Okay? So whenever you do this, I'm going to have, not the line, I'm going to have 2 factorial, or 2 times 1, times 2 times 1, times 2 times 1. And then I'm just going to start basically canceling things out. 2 and 1. Okay, 2 and 2 made 4. And I'm going to multiply everything else on top. So 10, 9, 8, 7, 6, 5, and then the 3.
Are all those 2 factorials getting multiplied with each other?
Yeah. I mean, it's 8. Or you can just all I did was just take 2 and 2 was 4, and that's why I got rid of the 4 here. And then I had 2 and 1, I just got rid of all that. It's all the same. Like I could have just gotten rid of the 8. You know what I mean? And done it that way. So, same way, I don't remember what my value is. whenever I multiply that?
453,600.
That seem right? I think that's right. I just didn't write it down. So then on 10, where it says you have the word Mississippi, there's a lot of things I can change, right? There's a lot of letters that repeat themselves. So in the word Mississippi, how many different spots do I have? How many letters? Or place? 11, right? So I'm going to have 11 factorial on top. It's just a matter of what I need to divide everything by on the bottom. So I have 11 spots. That's where the 11 came from. And then my repeat letters are I, S, and P. How many times does I repeat itself? 4 times. So since it repeats itself 4 times, I'm going to have 4 factorial. Do what? How many times does S repeat itself? 4 times. So I'm going to have another 4 factorial on the bottom. And then how many times does P repeat itself? 2 times. So I'm going to have 2 factorial. Every time I have a repeatable letter, value, whatever, okay, I have to divide by that factorial number of however many I have. So then whenever I take everything up top, I'm going to have 11, 10, 9, 8, 7, 6, 5. Can I stop at 5 for one of them? Because what's going to happen at 4, 3, 2, and 1, for one of those 4, isn't that one of the factorials? Okay, and then do it again. 4, 3, 2, and 1. Because everything in the first here is just going to cancel there, right? And then it just becomes kind of start getting rid of what I can get rid of. I have 4 and 2. There gets rid of my 8. I have 3 and 2. That gets rid of my 6. So realistically, I'm only multiplying 11, 10, 9, 7, and 5 together. Okay? Because everything else down here goes away. So what do we come up with? 34,000. What was the rest of it?
650.
650.